everyone, hope you're all doing well. As promised, I'm going to be doing another video on Redox, and this will be probably the last one in this playlist because it is the ultimate balancing redox equations. So before we start, it is my request, if you don't know already, you have to know the basics of redox and you need to know how to assign oxidation numbers. So I will link those videos. They are in this playlist. So make sure you watch that beforehand because I'll be referring to those during the video. Alright, so the question that I'm using today is from the State Examinations Commission, of course, and it's 2022 Higher Level Question 11, Part 5. Alright, let's get started. I will give a quick summary of what we did at the very end, so it'll be easier for you to follow, or you can just, screenshot the video or whatever, or revisit the video to do this again. Okay, let's start. So this question is asking, the following unbalanced equation describes a reaction that occurs in aqueous solution. Assign oxidation numbers, and hence or otherwise balance the equation. Okay, so what we have here is Mn plus 2 plus bismuth O3 minus plus H plus, and that becomes MnO4 minus plus Bi3 plus and water H2O. Okay, so one thing that you need to understand is, again, basic, it is unbalanced. This is not the equation that would occur if these chemicals would react. This is not the correct mathematical formula. So it is your job to find how it should be. Alright, so usually when I see this question, I'll be extremely confused of where do I even start? So that's why we need to know about oxidation numbers, and that's why I said you need to watch the video. Alright, so first thing, as the question says, is that you need to assign oxidation numbers. If you don't do this, you will lose marks because the question is particularly asking you to assign oxidation numbers. So I'm going to rewrite the equation down so I can do some stuff. So I'm going to start oxidation number assigning. This is Mn plus 2, so that's going to be plus 2. Bismuth and O3 minus. We know if it's a minus, that should be the charge, that should be the total charge. So I'm going to do a small rough work here. BiO3 minus. So my final answer should be minus 1. I know oxygen is always minus 2. But there's 3 oxygen here, so I'm going to multiply by 3. And that's going to be minus 6. Minus 6, now we don't know bismuth, so that's going to be x. Alright, so this should be straightforward. X is equal to minus 1 plus 6, and that's going to be 5. So bismuth is 5, so I'm going to write that on top. I'm going to rub this off. Do not rub off your work in your exam. Your examiner needs to know where did you get all these numbers. Okay, so that's going to be minus 2, not minus 6. It's always the one element that you write. So it's always one element. So oxygen just by itself is going to be minus 2. Don't worry about the 3. Forget about the 3. 3 only matters if you don't know the other element that is joined together with it. Okay, next up. Hydrogen. Hydrogen is plus 1 here because it's an ion here, so that's going to be plus 1. Straightforward enough. I'm going to do the next one. Okay. Oxygen is going to be minus 2. MnO4 minus. Again, the final answer should be minus 1. Minus 2 multiplied by 4 is going to be minus 8. So that's going to be minus 8 plus x. X is equal to minus 1 plus 8. X is therefore going to be 7. Okay, next up is bismuth plus 3. Bismuth plus 3 is just going to be straightforward, plus 3. Now oxygen, H2O, oxygen, H2O. So you always do the thing that you know first. So oxygen is the handiest, that's going to be minus 2. H2O, so this should be balancing into 0 because this is a compound. We know one hydrogen is plus 1 and 2 hydrogens will be plus 2. Plus 2 minus 2 is 0. Okay, so that's straightforward enough, that's plus 1. Now the next step that you have to do after you're sure that you've assigned the correct oxidation number is to check for differences. Okay, so this is your left-hand side and this is your right-hand side. Okay, I'm looking at Mn2+, so that's manganese. Manganese on the left-hand side is not the same as the manganese on the right-hand side. So I'm going to do something like this. Okay? So +2 become +7, so there is a difference. Okay, let's check the bismuth. Bismuth became from +5 to +3. Okay, something's wrong there. So I'm going to put something like this. So I'll come back to that. Oxygen is -2. Right hand side is also -2. No problem. Hydrogen is +1. The right hand side is also +1. So that's okay. So the thing that we have to work with is manganese and bismuth. Now you need to check out which one is oxidizing and which one is reducing. Okay, so in chemistry maths, we know there's a small difference than your normal maths. So that's going to be manganese became from +2 to +7, so that is a loss of electrons. Bismuth became from +5 to +3, so that's going to be a gain of electrons. Whoops, that's not a good G. Of electrons. Okay, so we know from our previous videos, gain is reduction. So bismuth is being reduced. And our manganese is being oxidized. Okay, which makes sense because most probably this equation, and now that it says aqueous equation, from your chemistry knowledge, you can probably guess that that compound that they would probably use is going to be potassium permanganate. All right. So potassium permanganate, we know it's a very strong oxidizing agent or oxidizing solution. So that makes sense that it's oxidized. Okay. So I'm going to balance this now. Since there are too many compounds here, it's going to be so confusing. So I'm just going to rewrite half equations here. So what is half equation? Mn plus 2 became Mn plus 7. You don't have to write the rest. I know in the right hand side it's Mn 04, but that doesn't matter. We're just going to do the compound or the element that has changed. Okay, so that's the first equation. And the next one is going to be bismuth. Oops. And bismuth plus 5 became bismuth plus 3. I'm sorry, my system had updated, so this application that I'm using, it's not the same anymore, so this video is a lot more slower. I'm sorry. Okay, now let's look at the differences here. This became from +2 to +7, so that means it's a difference of 5 electrons. Okay, so this became from +5 to +3, so 5 minus 3 is going to be 2 electrons. Now what do you have to do to balance? Very straightforward. You just multiply with each other. Okay? So multiplying the first equation by 5. Whoops, sorry, not 5. Multiplying the first equation by 2 and multiplying the next equation by 5. Do you see what I did there? I basically swapped the electrons and then I'm going to multiply. So when I multiply, the answer is going to be. So when I go back to the equation, we're going to start from the left-hand side, always the left-hand side. So this is how the original equation looked like. So I'm going to add in my extra changes. So Mn became 2. Mn became 2. Bismuth became 5. Okay, so what I did to the left-hand side, I have to do to the right-hand side. So Mn, again, here became 2. Bismuth became 5. Okay, so I'm going to write a small table underneath, so it's going to be easier. All right, so this is the left-hand side. This is the right-hand side. Mn equals 2. Mn here is also equal to 2. Bismuth is equal to 5. Bismuth here is also equal to 5. Now, look at the other elements. Oxygen here is actually 3 multiplied by 5 because there's 5 of O3s, if you know what I mean. So 5 multiplied by 3, that's going to be 15. Let's check the other side. Oxygen is going to be, see there's 4, and that's going to multiply by 2. So that's 2 times 4 plus 1 oxygen. Don't forget that water. Many people forget the water. Plus 1. So that's going to be 8 plus 1, 9. That's not good enough. We need 15 here and 15 here. So what do you have to do? Don't go adding anything more here on the MnO4. We have that set. Mn is fixed. Don't, add more stuff there and get it complicated. It's not like you cannot, it's just going to make things complicated. So the best thing to do is to make your modifications to the water because there's oxygen there. So when I do the calculations, 15 minus 9 is going to be 7. So 7 in front of my water. So there's 7 oxygens fixed. Oxygen is balanced now. Okay, oxygen, nice and well. Now I have one more left, and that's hydrogen. So hydrogen here, 7 multiplied by 2 is 14. The hydrogen here is only 1, and the hydrogen here is 14. Now, what am I going to do? The best thing to do is to simply multiply my 1 oxygen or hydrogen here by 14. So that's going to be H equals 14. Gonna change that up top. And that'll be 14 H plus. I'm very sorry for the messiness. I'm going to rewrite this again. Final answer, 2Mn plus 2 plus 5BiO3 minus plus 14H plus all became, I'm going to do this here instead of the right hand side, oh my gosh, 2MnO4 minus plus 5Bi3 plus and finally 7H2O. You have to write this at the end and say this is the final answer, and please do not, even though this looks like some horror movie and it's all red and mess, you are getting marks with this mess, right? So this shows your thought process, so do not rub this off by any means. Just make sure you write this a lot nearer than I did, please, and write this here instead of, make sure you write it here and not underneath, okay? I just didn't have any space. I'm constricted with time. Okay, so that's how you do balancing redox equations. Very straightforward, actually. I know there are times when oxidation numbers become like a half and all those things, but it's just about using a bit of logic. Okay, so watch this video as much time as you want over and over again until you understand it. And I highly recommend you to watch the whole playlist as a whole, the entire 3 videos, I think, if I'm right. You'll be set with this oxidation reduction chapter. So the very best of luck to all of you. I'll just put a small summary at the end in a small post-it so you can read over that again. All right, thank you everyone. God bless you, and I'll see you with another video soon. All right, take care. Bye.